Okay, class. Now I want to introduce standard basis vector and unit vector. So what are standard basis vector? Like you can see, I, J, K usually refer to that as 1, 0, 0, J as 0, 1, 0, K as 0, 0, 1. Or in two-dimensional cases, here is I equal to 1, 0, J equal to 0, 1. So what does that mean? That just means the little red vector here, this is I, okay, that's 1, 0, and this is J. So in the standard positions, 0, 1. In the three-dimensional cases, that would be, all right, 1, 0, 0. That would be 0, 1, 0. Finally, this one will be K. So this will be I, J, suddenly K will be 0, 0, 1. So that is called standard basis vector. So any vector can be expressed as a combinations of I, J, and K in three-dimensional cases. All right. So let's look at some example here. Here's an example, right? If you have a vector 1, negative 2, and 6, let's say that they are Ji minus 2j, so the 1 was usually abbreviated without writing anything being 1, and plus 6k. All right? So that's any vector can be expressed in terms of that. And another example is, all right, here is another example. If a equals to I plus 2j minus 3k, and b is 4i plus 7k. So the missing term, 0j, you're going to have to come up with it yourself. All right? So express, all right, 2a plus 3b in this case, all right, in terms of I, j, and k. So in this case, 2a equals to plus 3b. Let's go ahead and do it all together. 2a plus 3b equals to 2 times I, just normal, like a normal algebraic operations, plus 3b, which is 4i plus 7k. All right, so kind of collect the like term. Okay, so it's a 2 plus 12, which is 14. So it's a 14i plus 4j, but no j here, so you just 4j. And the negative 6 plus 3 times 7, 21. That would be 21 minus 6 was plus 15k. Basically, that operations, vector operation according to the standard basis unit. All right. Then we're going to definition what's a unit vector. What is a unit vector? A vector with length, magnitude, or length 1. Okay, so I, J, and K obviously are unit vector. But given any vector, can we make it into a unit vector with the same directions? All right, so here you go. All right, so find the vector, the unit vector. Unit vector usually we use the notation U that has the same directions as vector A. How do you do that? So given any vector, I don't know how long was that. So solution is this, right? So if you're given any vector, say, A equals to 2, -1, and -2. How do let's just say this is a vector A. The length obviously is not 1. How can I find a unit vector U is the same direction and its length equal to what? 1 is length as its length. All right. So the way we do is this, right? So solution we do is the length of A is this. So let the unit vector simply equals to, so remember this is scalar, right? The length of A, my bad. So we want to do is, put it on the, so this is scalar, all right, times A. So as a combination of these two is a what? Is a vector. So let's look at what is the length of U. Well, it's the length of, you define this, right? Well, this is a constant, so we can factor it out to the what? Outside the what? Outside the absolute value. Well, this cancels. Wow, look at that. The length equals to 1. Let's look at the example. Okay, find the unit vector that has the same directions as the vector 2i minus j minus 2k. All right, so from what we did before, the unit vector had the same direction with this current vector was simply just equals to 1 over the length of U of this current vector, which is what? 4 plus 1 plus 4, square of that, times 2, -1, -2. So the answer is, so that just happened to be 1/3, 2, -1, -2, or you can say 2/3, -1/3, and -2/3. So this vector, you can check, has length 1. Also the same direction as 2, 1, -2.